This is how to analyze an NMR spectrum practice problem. Let's say the question says, determine the structure for the following spectrum. Step 1, calculate the DBE, double bond equivalence, using the formula. There's other formulas, but this is mine. 1/2 X4, so this is things that bond 4 times, like carbon, plus X3, so this is things that bond 3 times, like nitrogen, minus X1, so halogens and hydrogens, things that bond 1 time, plus 2, this is a buffer. So given C4H8O, we would say 1/2 of 2 times the X4, so 4 carbons, plus 0, no things that bond 3 times, minus 8, because there's 8 hydrogens and no halogens, plus 2. If you do the math, then you get 1 double bond. So given our formula, we could say, there's carbons, there's N oxygens, maybe a ketone. So I'm just going to put this in my little legend, ketone possible. Then I go straight to the spectrum. Peak by peak, I do IMP. Integration, multiplicity, ppn. So at 2.4, we have a quartet peak that has an integration of 2. This is given in the question. So we're like, what is this? If the integration is 2, it means we have a carbon that's attached to 2 hydrogens, so a CH2 peak. Now its multiplicity, this tells us who its neighbor is. The neighbor formula is M is equal to N plus 1. So the multiplicity is 4. So hence N is equal to 3. So we have a neighbor that has 3 hydrogens. What could this be? A CH3 group. So now we have a CH2 connected to a CH3 potentially. But to know for sure, we must find the CH3 peak that's also connected to a CH2 in the spectrum, but we'll do this after. So now for the next peak, we have a ppm value of 2, integration of 3. What could this be? Well, if the integration is 3, it's probably a CH3. But now the ppm is around 2, so this is quite electron poor for a CH3 group. They should usually be around 1 ppm. And since its multiplicity is a singlet, this means it has no neighbors. What I mean by no neighbors, if I want to know the multiplicity of the CH3 group, I say, okay, I'm going to circle the hydrogen on the CH3. And now I'm going to count bond by bond to 3 bonds away. If I hit a hydrogen, that's a neighbor. So bond 1, bond 2, bond 3. Gotcha, circled it in orange. That's 1 neighbor. You can do this again. 1 bond, 2 bond, 3 bond. Second neighbor, multiplicity of 2, hence a triplet. Whereas the multiplicity of a CH3 group that's connected to a ketone, a 4' carbon, if you look at it and you circle the hydrogen on the CH3 and you count 3 bonds away, 1 bond, 2 bond, 3 bond, you don't hit a hydrogen. You have to count 4 bonds to hit a hydrogen. Hence, it's not J3 away. Hence, it is not a neighbor. So it is a singlet. No hydrogens that are within 3 bonds away from it. So this is diagnostic, if you have a formula sheet, of a CH3 group connected to maybe a 4' carbon with a ketone group on it. Or something electronegative, but we know there's no halogens in our structure, so that's why I'm inferring that it's connected to the ketone. Now for our final peak, at 1 ppm we have a triplet with an integration of 3. So this would be a CH3 group. And its multiplicity of 2 tells us it has 2 neighbors. And this corresponds to the other peak we found previously that had an integration of 2 with 3 neighbors. This is good. We found the peak. So now we say, okay, there is for sure a CH2 connected to a CH3 peak in my spectrum. And the ppm is very electron rich. So this does tell me, yes, it's connected to a CH2 because a CH2 is not electron withdrawing. Hence the CH3 will be electron rich. So now I always make a little legend. I always take my molecular formula and I'm going to subtract off the atoms of the structures that I know for sure are in my spectra. So I know there's a CH2 connected to a CH3, so I'm going to subtract off C2H5. I also know there's a CH3 group, so I'm going to subtract off CH3. What do we have left? All we have is a CO. Also know there's 1 double bond, so hence, oh wait, this carbon must have a double bond to an oxygen. What is it connected to? Well, what did we not have? Well, we knew the one CH2 had an extra group because all carbons like 4 bonds that it must be attached to. The CH3 group that was electron poor also needed 1 more bond, so put that as a question mark. So this final group is the question mark. So it's a C double bond to an O. So you just put that in place of the question mark. And you attach the CH2-CH3 group to the question mark. And you attach the CH3 group to the question mark. Hence, you get your structure. That's it, that's all. Hopefully this helps.